From the dawn of the universe to the shores of the moon and the skies above your head tonight, this is Astronomy Daily.
Coming up, James Webb has finally cracked a 4-year cosmic mystery. We'll tell you what those strange little red dots really are, and it's even weirder than you'd expect.
A brand new lunar lander just made its public debut, and it's aiming to lay the foundation for a permanent moon base. We have the details.
And there's a NASA spacecraft on a race against time. A robotic rescue mission is heading for an observatory that's slowly falling out of the sky.
Plus, a science-packed Dragon capsule is heading home from the ISS as we speak. There's a celestial triple play in tonight's sky, and we've got a space weather update for Aurora watchers.
It is Tuesday, June 16th, 2026, and this is Astronomy Daily, Season 5, Episode 116. I'm Avery.
And I'm Anna. Let's get into it. We're starting with a big one today. A mystery that has genuinely unsettled cosmologists since James Webb first opened its eyes.
We're talking about the little red dots, and if that name sounds almost comically understated for something that threatened to break our understanding of the universe, well, that's astronomy for you.
So let's rewind a little. When Webb began science operations back in 2022, astronomers noticed something deeply strange. Practically everywhere the telescope looked in the ancient, distant universe, in a period just a few 100 million years after the Big Bang, it kept spotting these tiny, compact, ruby red objects. They were everywhere, far too many of them, far too bright, and nobody could explain what they were.
The problem was that they didn't behave like anything in our existing models. They looked too massive and too mature to be young galaxies lit up by newborn stars, but they also weren't blasting out the X-rays and radio waves you'd expect from a supermassive black hole feeding on gas and dust. They seemed to break every box astronomers had.
Some researchers genuinely used the phrase broken cosmology, not because they thought physics had failed, but because these objects appeared in such numbers and with such properties that the standard story of how the early universe evolved simply couldn't account for them.
And now, 4 years later, Webb has handed astronomers the object they needed to solve it. It goes by the name Glimpse 17775, not exactly a catchy title, but it turned out to be the Rosetta Stone for this whole mystery.
A team led by Vasily Kokorov at the University of Texas at Austin observed Glimpse 17775 through a stroke of cosmic luck. Webb was actually pointed at a galaxy cluster called Abell S1063 as part of a program searching for something entirely else. Population 3 stars, the hypothetical first generation of stars in the universe. The galaxy cluster's gravity acted as a natural lens, magnifying what was behind it. And right in the field of view was Glimpse 17775, magnified beautifully, giving the team the most detailed spectrum of a little red dot ever obtained.
The data, published in the Astrophysical Journal on June 10th, is about as clear as it gets. These objects are supermassive black holes, but not in the way we're used to seeing them. They're in the midst of an explosive early growth phase, wrapped in dense cocoons of hot, ionized gas. The gas acts like a disguise. It scatters and absorbs the high-energy radiation that would normally give a growing black hole away, making these objects look red and compact rather than blazingly bright.
So the universe isn't broken. We just couldn't see through the costume.
And this finding also resolves something that had alarmed astronomers even further. Earlier estimates suggested these black holes were extraordinarily massive, which made the timeline for how they grew seem impossible. But the team's analysis shows the gas cocoon was distorting those mass measurements. The black holes inside the little red dots are likely around 100 times less massive than originally thought, bringing them back within the bounds of what our models can explain.
I think the thing that strikes me most about this story is what it says about how science actually works. 4 years of competing theories, genuine alarm among serious scientists, and then one lucky observation of one well-placed object, and suddenly the picture snaps into focus.
Serendipity and a very big telescope. A combination that seems to work remarkably well.
The little red dots are solved, and the universe, it turns out, was never broken, just very good at keeping secrets.
Story 2, and we're heading to the moon, or at least heading toward heading to the moon.
Yesterday, June 15th, Pittsburgh-based company Astrobotic held a public unveiling of their Griffin-1 lunar lander at the Moonshot Museum, which is co-located with their headquarters and has a large window into the clean room so the public could actually watch engineers working on the vehicle in real time while the press conference was happening.
Which is a nice touch.
Very nice touch. Now, Griffin-1 is significant on multiple levels. NASA has selected it as the lander for what they're calling the Moon Base 2 mission, part of the first phase of the agency's efforts to establish a permanent lunar outpost. Astrobotic CEO John Thornton described it as, quote, the first infrastructure-class lander going to the surface of the moon.
And it's carrying a substantial payload to prove that point. The largest is the FLIP rover, the Flex Lunar Innovation Platform from California company Astrolab. FLIP is designed to demonstrate critical technologies for future large-scale commercial lunar rovers. It'll be deployed in the Noble region near the lunar South Pole.
The lander is also carrying several other payloads, including Astrobotic's own Beacon Cube rover and the European Space Agency's LandCam-X, designed to help improve precision landing on future missions. There are also payloads from Japan, Canada, Germany, and, worth a mention for our audience, Australia.
Of course.
Griffin-1 is now preparing to depart Pittsburgh for NASA's Jet Propulsion Laboratory in California, where it'll go through environmental testing. From there, it'll head to Florida, where the FLIP rover will be integrated ahead of launch on a SpaceX Falcon Heavy, currently targeting the fourth quarter of this year.
Now, Astrobotic's previous mission, the Peregrine lander in early 2024, unfortunately didn't make it to the surface due to a helium valve issue early in flight. But Thornton emphasized that the in-house avionics and systems performed as expected on that flight, and the post-anomaly review was thorough. Griffin is the next chapter.
A moon base has to start somewhere, and if all goes to plan, this could be one of the most significant robotic landings in the history of lunar exploration.
We'll be watching very closely.
Story 3 has all the drama of a rescue mission, because that's exactly what it is.
NASA's Neil Garrow's Swift Observatory has been one of the workhorses of high-energy astrophysics since it launched back in 2004. 22 years of catching gamma-ray bursts, the most powerful explosions in the known universe, and relaying that information to ground telescopes fast enough to catch the afterglows.
It has acted, as NASA put it, as a kind of cosmic dispatcher, spotting a burst and immediately alerting other observatories to follow up before the light fades. It has been extraordinary. But now Swift has a problem.
Like all spacecraft in low Earth orbit, Swift experiences drag from the upper atmosphere, which gradually lowers its altitude over time. That's manageable, except that the recent surge in solar activity has dramatically accelerated the process. The orbit has decayed faster than expected, and without intervention, Swift would re-enter Earth's atmosphere in the autumn of this year.
Now, many spacecraft simply do that at end of life. It's a normal retirement. But NASA looked at this situation and saw an opportunity to do something unprecedented. In September 2025, they awarded a contract to a company called Catalyst Space Technologies in Flagstaff, Arizona, to build and launch a robotic servicing spacecraft called Link to rendezvous with Swift and physically boost its orbit to a higher altitude in less than a year.
That turnaround is remarkable in itself. Link went through testing at Goddard Space Flight Center, was transported to NASA's Wallops Flight Facility in Virginia, and was integrated into a Northrop Grumman Pegasus XL rocket. On June 12th, that rocket was attached to the belly of Northrop's Stargazer, a modified L-1011, and is now ready for the trip south.
Link will launch from Kwajalein Atoll in the Marshall Islands later this month. The air launch approach gives flexibility in reaching Swift's orbit that a ground launch couldn't match. Once in orbit, Link will use its 3 ion thrusters and robotic arms to rendezvous with Swift and execute the boost.
NASA is calling it bluntly a fast, high-risk, high-reward mission. There are no guarantees. This type of on-orbit servicing at this speed has never been done before. But if it works, it not only saves a beloved and productive science mission, It demonstrates a capability that could be transformative for the future of the entire spacecraft fleet.
A NASA media briefing on the mission is scheduled for tomorrow, June 17th, so we'll likely have more details coming. We'll keep you across it.
Swift has spent 22 years watching the universe's most violent moments. Here's hoping it gets a few more years to keep doing exactly that.
Story 4 is happening right now as we record. A SpaceX Dragon cargo spacecraft supporting NASA's 34th Commercial Resupply Services mission has undocked from the International Space Station today, Tuesday, June 16th, at around 12:05 in the afternoon Eastern Time.
Splashdown off the coast of California is expected tomorrow morning, June 17th, at around 8 a.m. Eastern.
Now, the Dragon arrived at the ISS on May 17th. Carrying nearly 6,500 pounds of supplies and equipment for the Expedition 74 crew. But what it's bringing back is what makes this particularly interesting.
Because packed inside Dragon right now are some genuinely remarkable research specimens. Blood stem cells harvested by NASA flight engineer Jessica Mayer inside the Kibo laboratory module have been growing aboard the station and are now heading home. Researchers are exploring whether the microgravity environment of space could allow these cells to be developed into therapies for blood cancers and immune diseases that are difficult to manufacture on Earth.
There are also samples of bioprinted organ and cartilage tissue produced using three-dimensional printing techniques aboard the station, and materials developed for what are described as DNA-inspired cancer treatments.
The capsule is also carrying hardware, including equipment related to cryogenic fuel storage experiments, data that will be valuable for future deep space missions.
The ISS has long been described as a laboratory in the sky. Missions like this are a reminder of what that actually means in practice, that the unique conditions of orbit allow science that simply isn't possible on the ground, and that the journey home is sometimes the most scientifically significant part of the mission.
Safe travels, Dragon, and fingers crossed for a smooth splashdown tomorrow.
Now, for something you can actually go outside and see tonight, and it is a lovely one.
Right now in the western sky after sunset, 3 planets are visible to the naked eye simultaneously: Venus, Jupiter, and Mercury. That alone is worth stepping outside for. And tonight specifically, the slim, waxing crescent moon is joining the party, appearing between Mercury and Jupiter in the western sky about an hour after sunset. Tomorrow evening, June 17th, the moon will drift further along and sit next to brilliant Venus.
Mercury is the trickiest of the 3 to spot. It's much fainter than Venus and Jupiter, and sits very close to the horizon, so you'll want a clear sky and an unobstructed western view. It actually reached its greatest eastern elongation, its furthest point from the sun as seen from Earth, just yesterday on June 15th. So right now is genuinely the best time of this apparition to find it.
Venus, as always, is unmissable, the brightest object in the sky after the sun and the moon. And Jupiter sits just below it, the second brightest, both of them easy to find.
For our listeners in Australia and New Zealand, the geometry will appear flipped compared to Northern Hemisphere charts, with the planets appearing to the right rather than the left as they track west after sunset. But the view is equally beautiful.
The crescent moon alongside 3 planets all setting together in the western glow, it's one of those simple, no telescope required moments that reminds you why people fell in love with the night sky in the first place.
Get outside tonight if you can. And finally, a quick space weather update, which also ties in nicely with our sky watching story.
Forecasters at NOAA Space Weather Prediction Center are tracking a coronal mass ejection, a CME, that departed the sun on June 12th. It's expected to deliver a glancing blow to Earth today or tomorrow, June 16th to 17th.
The emphasis is glancing. A direct hit is not anticipated. But forecasters expect active conditions with a KP index up to around 4. And there's a chance of an isolated G1, minor geomagnetic storm. A G1 is the lowest level on NOAA's 5-point scale, but it can still produce aurora activity at high latitudes.
If you're in the higher latitudes of Australia, Tasmania, or New Zealand tonight, it's worth keeping an eye on space weather apps. The Aurora Australis won't be putting on a headline show, But with clear skies and a bit of luck, there may be some activity on the southern horizon for those in the right location.
June is generally a quieter time for southern aurora chasers, given the shorter nights as we head towards the solstice in just a few days. But the sun has been reasonably active this month. Earlier in June, there was a G3 watch issued for a series of more significant CMEs. And this is a reminder that space weather remains worth monitoring.
We'll, of course, keep watching and update you as conditions develop.
And on that note, that is your Astronomy Daily for Tuesday, June 16th, 2026.
A massive thank you for spending part of your day with us. If you're enjoying the show, please subscribe, leave a review, or share it with a fellow space enthusiast. It makes an enormous difference.
Find us at astronomydaily.io and follow us on social media at AstroDailyPod. We'll be back tomorrow with another full episode. Until then,
Keep looking up.
this is Astronomy Daily. Goodbye for now.